Okay, good afternoon, everyone. Thank you for attending today's webinar on HERS versus ERI. And this webinar will be recorded. Recording is posted to the Code Adoption Toolkit, which I'll post in the chat shortly. And if there are any issues with audio, please feel free to write me in the chat. My name is Erica DeLello, and I'm a project manager for Noresco. This series is sponsored by the Colorado Energy Office with training materials created by BuildTank. So Robbie and I have been working with the Colorado Energy Office to provide trainings just like this one. And we've got 2 other webinars on the list coming up over the next couple of months. So if you haven't registered for those already, I'll put the link in the chat shortly. And feel free to share those with any other folks that you might think would be interested. We also offer tailored group trainings or technical assistance for jurisdictions that are updating I-codes. I know this is a really, we're in a home stretch here where a lot of jurisdictions are looking at updating their I-codes before July 1st. So if you're one of those jurisdictions and you are looking for a little support on that effort, feel free to reach out to me and I can set you up with some technical assistance and some resources that we have for you all. So most of you who have, if you've attended these webinars in the past, you're probably familiar with the Code Adoption Toolkit and all of the resources that are available. But if you're not, please feel free to check out that toolkit. It's a wealth of knowledge and we're always adding new content. The one item I do want to highlight today is the Colorado Codes Helpline, and this is a resource for anyone in Colorado to help on any of the I-codes or REACH codes. So for example, if you're a jurisdiction and need assistance on a plan review or a homeowner or engineer with a question about code applicability, you can submit a ticket and a subject matter expert will get back to you in just a few days' time. And you can access this helpline, of course, through the Code Adoption Toolkit or through that QR code I've got on the screen now too. Just a couple of housekeeping items before I pass it over to Robbie is throughout the webinar, we do want to encourage questions. So please use that Q&A function and I'll let Robbie know at the end of the presentation so that we make sure we get through all of the content today within the hour. There's also the ability to raise your hand and ask a question directly. And then lastly, there will be a survey window that pops up following the webinar. If you could please take a minute to provide feedback, we can continue to improve on these or develop a webinar based on a topic that you suggest. There's a lot of opportunities here for us to continue providing trainings to you all. So today's presenter is Robbie Schwartz, and Robbie founded BuildTank to be a practical building think tank to do research, education, and work with builders to ensure their homes not only comply with the codes and programs, but perform as well. At BuildTank, they strive to use what they learn from their fieldwork to affect meaningful change in the construction industry. So he's also the new homes building advisor for the Boulder County's Marshall Fire. So with that, Robbie, I'm going to go ahead and stop sharing my screen and allow you to share yours.
Great. Okay, I think we're sharing now. Thanks so much, Erica, and thanks everyone for joining us today. I'm going to stop my video sharing right now and then let you concentrate on the slides. And we're just going to jump right in here because we have a lot to cover today, talking about the HERS ERI versus the IECC ERI score here. So we need to understand what ResNet is, the Residential Energy Services Network. Therefore, we'll get a better understanding of the HERS Energy Rating Index score. We'll also talk, obviously, about the IECC Energy Rating Index and why the 2 scores are different. So the whole objective of an energy rating score is to try to quantify, give us an idea of the quantification of the energy performance of a house here. And this is just one example of how energy is described and the use of energy is described in residential housing, and in this case also in commercial buildings as well. But we are going to focus in specifically on the ERI and how the ERI works here. Now, the IECC has adopted an ERI approach for code compliance as one of the compliance options that you can choose in the 2015 IECC. But you'll see that the ERI has been around much longer than 2015. And in fact, its reference home is based off of the 2006 IECC. But before we get there, let's talk a little bit more about ResNet. So ResNet stands for the Residential Energy Services Network. This is a nonprofit organization that was founded in 1995, actually by NASIO, which is a energy efficiency group, but also by the mortgage industry way back when in 1995. ResNet is this nonprofit or membership organization that's governed by a board of directors, and ResNet is recognized as a standard-making body now. They've been developing a number of ANSI standards, and I'll show you those here in a minute. Ultimately, the mission of ResNet is to make the energy use of all homes transparent, thereby driving residential sector energy use toward net zero, ultimately. In 2022, the last year we have data for, they did over 300,000 homes that got energy rated, and the average index score was 58. What was interesting to me is that I updated this slide the other day, and I had 2019 data on there before, and they'd done just over about 250,000 homes in 2019. That's the yearly amount, not the cumulative amount there. But the average index score was 59 in 2019. So the scores haven't gone down substantially, but they are demonstrating that new homes are performing quite well there. And we'll get an idea of what, how to understand the index score as well as we move along here. The ultimate goals of ResNet in this mission is to try to get at least 50% of all new homes HERS rated. They're trying to drive that score of new homes down there. And the 25% of the homes rated also using what's called a water efficiency index score that they have as well. They've also just created a carbon index score, so they're trying to create more and more interest in that. And then there are energy efficient mortgages out there, and they're trying to continue to gain traction with the energy efficient mortgages. And that's really what the whole point was in 1995, was linking energy ratings with energy efficient mortgages. And that's why the mortgage industry associations were one of the key groups that helped create ResNet back in 1995 here. ResNet creates and maintains a lot of different things. So there's the HERS Energy Rating Index score itself that allows us to compare the energy performance of homes. There's the HERS H2O rating system there that's out right now. There's the new carbon index score as well. There's the national training and certification and quality assurance standards that home energy raters work. So ResNet is ultimately the governing body over home energy raters around the country. They also have they actually have more than three, but there are three main standards or ANSI standards that they've created and are using to help quantify and express, I guess, the energy and water use and carbon use in houses there. And then they have these standard development committees, because the ANSI standards are a continual maintenance standard. So they have standing committees that work on these standards throughout the year and year over year as well. ResNet is committed to quality assurance and ensuring that we get better quality in this work that they kind of govern and lead here. So there are ways of better achieving the goal and setting the standards They've established these standard setting committees. Each committee's purpose is to provide a ResNet board with policy implementation and technical guidance. So ResNet is governed by a board of directors, and they're getting guidance by these different committees here. So they have a variety of different committees that are working on ethics, from ethics to software consistency, and then their standard management boards are working to ensure that the ANSI standards that they've created are being maintained and supported as well here. So there are kind of two standards that ResNet works with. One is called MNHERS, or the Mortgage Industry National Home Energy Rating Standards. Those were the originating standards that ResNet was founded on back in 1995. And some of the chapters of those standards have been made into ANSI standards. The most significant one is Standard 301, which is the standard that governs the way that an energy rating index score has been made. So in essence, what used to be private domain within the mortgage industry national home energy rating standards has become a publicly used standard in the 301 standard for how to generate an energy rating index score. ResNet standards are recognized by industry and government bodies. They're used to accredit ratings and trainings and software providers. They're used to do quality assurance oversight over home energy ratings, verification of energy savings and energy efficient mortgages, which are termed EEMs, or EIMs, energy improvement mortgages, are also out there as well there. EEMs are generally for new construction, and EIMs are often for existing homes out there. So we should also understand that an energy rating index score can be layered or performed. An energy rating can be performed to create an energy rating index score on existing homes as well as new homes there. They also are an oversight organization for the Energy Star program, the DOE Zero Energy Ready Homes program. And now they're working with code compliance with the IECC and the International Energy Conservation Code there. Federal tax incentives. There was the 45, or there still is the 45L tax credit that builders can achieve. It used to be calculated, or basically you used an energy rating index score and process for evaluating a house to develop a report that would demonstrate compliance with the federal tax credit so that a builder could claim $2,000. Now the federal tax credit is based off of the Energy Star program and the DOE Zero Energy Ready Home program. So if you build a house that qualifies for the Energy Star program, you can get a $2,500 tax incentive, or a $5,000 tax incentive if you build to the DOE Zero Energy Ready Homes program. And both of those programs utilize a home energy rating as part of the means of qualifying those houses and certifying those houses under those programs there. How does ResNet's standards get developed? Well, ultimately, anyone can propose a new standard or make a proposal to change any component of a standard. And therefore, these standards, after they've been published, are under continual maintenance there. So you have to make a proposal to the Standard Management Board. If the proposal fits the scope of ResNet's standard, it will be accepted there after going through a variety of debate and discussion, really, in this kind of more open format there. These accepted proposals are assigned ultimately to specific standard development committees, and then they are fully developed into a standard that are posted on the ResNet website for public comment there. And then the public comments are ultimately reconciled and addressed. Each public comment has to be addressed by a committee. And then ultimately a recommendation is made to the Standard the resident board of directors to formally adopt the proposal and incorporate it within a standard that they already have there. They could potentially also create new standards as they've done in the past. So the standards that they have right now that are most often looked at are the standard 301, which is the standard for calculation and labeling of the energy performance of dwelling and sleeping units using the energy rating index score. But they also have the ANSI 310 standard, which is a way of measuring and quantifying the performance, basically doing a commissioning exercise on HVAC systems, so that process can help grade the performance of that system and can be incorporated in the calculation of an energy rating index score. And then the ANSI standard 380 is a standard for how to actually perform duct testing, air leakage testing on a whole house, so a blower door testing and duct leakage testing, as well as ventilation measurements. And then they also have the ANSI standard 850 and 1201 here as well that you can see here. Those standards aren't used as much, and the carbon calculation standard has yet to fully be released, I believe. Yeah, so the 850 is the water calculation standard, and the 1201 standard test evaluation building energy analysis tool. So ultimately, they're trying to get consistency in how energy models are actually working and performing out there. So what is an energy rating index? An energy rating index in its heart is an asset rating. And an asset rating means that it's ultimately looking at all of the energy use within that score, within that home, and evaluating it as an asset to that home, and then putting taking all of that energy use and associating it onto a scale. So you can think of the scale like a golf score. The lower the score, the better here. And that actually changed, I think in the early 2000s. It used to be an ascending score. Now it's a descending score. So 0 on that scale would be equivalent to a 0 energy home. You can also think of the energy rating index score kind of like a miles per gallon rating for a house. So it doesn't matter how big the house is or how small the house is or who manufactured the house is, you can get an idea of its energy performance in the same way that you can get an idea of the performance of a car, regardless of who built that car or the size of that car there. When you're looking at an energy rating index score, you're looking at the performance of a house that you're actually doing a rating on in comparison to what's called a reference home. So within the body of the software, you have two homes. One is called the reference home and one is called the rated home. The rated home's energy characteristics are compared to the reference home and then associated on the scale based off of its performance. And the scale is fixed at 100 of the reference home, and the reference home is equal to the 2006 International Energy Conservation Code. So if you had a house that scored 100, it would be equivalent to that 2006 IECC. If you have a house that is 50 on the scale, then it's in essence, it's 50% more energy efficient than the 2006 IECC, as each point on the scale is equivalent to about 1% of energy use in reference to that 100 kind of benchmark score there. So a HERS energy rating index of 0 or just an energy rating index of 0 is equivalent to a 0 energy home. And remember, that's a net zero energy, meaning that you can still have gas being used in that house. And over the course of the year, the gas usage and the electric usage is netting each other, or the production, I guess, of that is netting each other out over the course of the year. Now, the Department of Energy has used this scale to give us an idea of what the average existing home is scoring. So you can see that we can have homes that score above 100 as well. I think the worst performing house that I've worked with was up in the 250 range, and the best home that I've worked with was down in the -20 range, meaning that it has a large solar PV system on it and is producing way more energy than it's actually using there. So it's putting that energy back into the grid, hopefully, there as well. So the structure of the ResNet system here to be able to implement these ratings that are generating energy rating index score is based off of this provider system. So a provider is someone that services the needs and supports energy raters, builders, and code officials, and others in the building industry. ResNet ultimately accredits providers. They're the key partners that maintain and improve the MNHERS and the ANSI standards there. And there's a variety of different types of providers out there. So there's providers for software tools, there are actual rating providers, there's quality assurance providers. If you are sampling, generally sampling happens with multifamily more often than single family, but it's a big contested issue in the energy code world as well, now that energy ratings or really the energy rating index score has been adopted into the code. It looks like in the 2024 IECC that there will be some level of sampling that's allowed, but it's probably going to be limited to stack multifamily residential buildings there. We also have accredited rater training providers and accredited energy smart contractors and educators that help with educating others in the industry here. And then we had the water sense providers as well. So rating providers have the responsibility of ensuring that quality of these rating services are actually happening. They're responsible for administering rating programs here. So there could be slight possible differences from rating provider to rating provider in the way that they actually implement and administer their rating program there. They're ultimately responsible for certifying the raters. So ResNet doesn't certify the raters, it's the rating provider that certifies the rater. Selection of accredited rating software tools, meaning that there are a variety of software tools that are out there. The provider chooses which rating software they're going to use in their providership. And ultimately, an energy rater aligns themselves with a provider to get accredited, to get access to the software, to have quality assurance done on them on a regular basis, and then potentially to get marketing and other types of services that a provider might offer there. Now, training providers really provide the training so that a rater can ultimately become certified by an accredited provider. Sometimes a provider is a rater training provider as well as a rating provider. Sometimes they are separate organizations. Almost always, I don't know of any rating provider that's also a software provider, but software providers are determining these calculations necessary to produce the home energy rating score. They're using the ANSI standard 301 as their guide through the process. And then ResNet has oversight over the software providers to ensure that there's consistency amongst the different softwares that is creating the energy rating index score for the HERS or for ResNet in essence. Home energy raters themselves are individuals who are certified by an accredited provider. They're certified to inspect and test a home in order to evaluate what's called the minimum rated features and complete the home energy rating. So within the 301 standard, there is a list of the minimum rated features. So you're looking for these assets that are in a home, and you're trying to understand how you're going to evaluate those assets. So it's important when we start thinking about how the energy rating index has been adopted into the code to understand that a HERS rating is an asset rating to develop a score that's kind of like this miles per gallon score. The minimum rated features are the things that we need to look at to assess the assets that are in the house, and then ultimately figure out how to model them to associate them on the energy rating index scale there. From the perspective of developing a HERS rating or an energy rating index score, we don't care how the system or how the insulation or how the mechanical system has been installed. What we care about is how we evaluate that asset and model that asset to create the energy rating index score there. So it's a very different mindset from the perspective of doing a code compliance rating. If we look at a rating as a systematic way of evaluating a house, we can think of it as a rating to do an energy rating index score, or a rating to do code compliance or compliance with a program like Energy Star, for example. So an energy rater, so how are home energy raters ultimately certified? They have to demonstrate that they have mastered the skill set. And the skill set is defined in Chapter 2 of the ResNet standards. And those are the MNHERS standards, or the mortgage industry standards, not the ANSI 301 standard here. The ResNet's training providers provide a curriculum that's accredited by ResNet. The instructors are certified by ResNet, and all home energy rater candidates must pass a national exam. After they've passed the exam and taken the class by the training provider, they have to perform at least 5 ratings under the supervision of an accredited field assessor, which is basically a certified rater that has gotten another designation. And then they can, and then the home energy rating candidate can be certified as an accredited rating from a provider that's ultimately going to certify them. So remember, it's not ResNet that certifies the rater, it's the rating provider that ultimately certifies the rater, and the rater provider that provides quality assurance and other services to that rater there, including access to the software to generate the energy rating index score. So an energy rating begins with a from plans rating. This is basically a software analysis of the proposed design there. The analysis yields this projected pre-construction energy rating index score when we're talking about new construction here. We can also remember that we can do an energy rating on an existing home and get the as-is energy rating index score for an existing home. So we can do it for new construction or existing construction. But because the industry really has moved to primarily using it for new construction, this is kind of outlining that process here. So before construction begins, every energy efficient improvement or option can be modeled to ensure that the house meets the code or program that it's working with there. And then during construction, the rater conducts a minimum of 2 on-site inspections. Often it's more than 2 inspections, but at a minimum, you're going to go out for a rough inspection to verify insulation and air barrier and duct sealing, duct testing, all those types of things. And then at final, you would do another potential insulation inspection, those things that you couldn't see at a rough stage. You'd be evaluating ventilation, blower door testing, duct leakage testing to the outside. All of these things are listed out as these minimum rated features that need to be assessed in order to calculate an energy rating index score here. So again, you can see that it's different than doing a code compliant inspection. You're looking at these things to evaluate how they've been installed, in essence, without a value judgment, so that you can assess the energy rating index score. You can do the energy modeling to create that energy rating index score here. And then you ultimately get a confirmed energy rating index score for that house here. There is another designation besides an energy rating, rater. There's the energy rating field inspector. This is a individual that's certified by a quality assurance provider and a rating provider there to conduct field inspections only. So they are not developing the energy rating index score. They're gathering information in the field and then taking that information to a certified rater. Therefore, they need to work under the direct supervision of the certified energy rater. It's the energy rater and the energy rater alone that has access to the software to develop the energy rating index score itself here. They cannot conduct energy modeling, but they can do all the inspection work that's out there. And again, they have to be able to go through a training process to be able to identify all the minimum rated features and to assess and test those things correctly here. So a rating field inspector, or RFI, has to complete 3 mentored field inspections. They have to the qualified mentors include HERS raters or other assessors out there. They have to at least have 1 inspection done in rough inspection and 1 at final inspection. And then they have to have 10 supporting photos that document each of the features of the home there. And all required RFIs are tasked during the field evaluation. They have to successfully complete for at least 1 home before they can get their designation as a field inspector themselves there. And then that's all on top of taking a class and passing a written exam as well. So in this kind of the same way that an energy rater goes through this certification process, a rating field inspector will go through this certification and mentoring process as well. Now, we're not going to talk much about the water efficiency rating system here, but ultimately it's a whole house water efficiency rating score that's available out there. And ResNet has created a standard because water efficiency is becoming equally as important as energy efficiency, especially with new home construction there. And you're starting to see some jurisdictions that are linking permitting to some level of water efficiency in the houses that are being built out there. The newest index score that ResNet has developed is the carbon rating index. It's all about operational carbon there. And it gives you within the standard the means for calculating the carbon index score. And you're going to start seeing this become more and more a focal point of what energy raters are doing and offering to builders out there as well. So we have this energy rating index process. We have it. We begin with an energy efficient plan review. We build the envelope and we do the leakage testing. We do the duct leakage testing in that house. We look at all the things behind drywall, and we might do some verification compliance for the IECC as well. But we need to remember that calculating and generating the energy rating index score is different than verification of compliance with IECC there itself there. So we need to remember that those can be different things there as well here. Quality assurance is also done for energy ratings under ResNet. So this is something that is important to realize, that quality assurance and the standards that have been created to do quality assurance on ratings are currently only being done for HERS energy rating index ratings, not for IECC energy ratings that might be happening out there to develop the IECC energy rating index score. When you're talking about the HERS energy rating index score, you have a rating provider that employs a quality assurance designee. These quality assurance designees can be employed by the provider, or they can be independent folks as well that work outside of the providership and provide their services ultimately to a provider, but they're not under in essence, the ownership of that provider there. quality assurance is provided on 10% of the building software files and 1% of each certified confirmed rating that a rater does in the field. So every year, the quality assurance designee has to look at a minimum this percentage of the rater's work in the field there. Remember, however, it's not on the IECC energy rating indexes that are created. It's only on the HERS energy rating index where this quality assurance is actually happening there. The ResNet performs quality assurance on the rating providers. So we have QADs and providers doing quality assurance on the raters, and we have ResNet that is doing the QA on the providers themselves there. And then these ratings ultimately are getting uploaded into the new national registry. The national registry has been around for not quite 10 years, I believe, here, but it's a registry that contains information on all certified raters, but also on all certified energy rated homes that have been done out there. So certified ResNet HERS raters, this is a public way of finding out what raters are out there and what standing they're ultimately in. Are they in good standing? Are they not active right now? What is their standing within the home energy rating world that's governed by ResNet? So you can go to this website and you can type in the name of an energy rater and you can see if they're in good standing or not with ResNet. The other side of the registry are the homes that are actually uploaded to the registry itself. And when you have the registry information there, you can go to this website and you can type in the address of the home and you can see if that home has been energy rated or not and what the score is that's associated with that house there. Now, in the process of uploading the information to the registry, the software analysis gets uploaded to the registry as well. And ResNet is now starting to compile a pretty impressive database on the energy performance of houses. Not only the energy performance, but also, what is the quality of the install, grading of the insulation that's been installed, what is the typical furnace that's being installed in different regions and whatnot. And some municipalities and some of our national RIOs or regional energy oversight kind of organizations like SWEEP and NEEP, they're starting to get some of that information to impact code development and other energy performance programs that are being developed across the country here. ResNet also has a code of ethics that every energy rater needs to work with. And whenever a ResNet HERS energy rating index is created, this code of ethics or this disclosure form needs to accompany that rating there as well. So remember, this is for the HERS energy rating index. It's not specifically for the IECC energy rating index as well. Quantifying the energy use of a score. So how does the software actually work to be able to do this? So ultimately, what we're doing is we're doing a takeoff of the house and we're inputting that house into a software so that we can figure out what its delta T location is. We have a defined temperature for our heating season and our cooling season based off of code, based off of ASHRAE standards. And we need to know what is the heat loss and heat gain through those building assemblies there. So every building component that is entered into the data or into the software data there is entered with a location and its delta T location. So in this case, we have the condition space defined by the picture in the upper right-hand corner. It's 70 degrees inside, it's 10 degrees outside. Our delta T is 60 degrees, and we can understand the heat loss or heat gain that's happening through each of the building assemblies there to get an idea of its energy performance there. So when we've done this takeoff and we've built the house inside of the software goes a step further and it creates what we call a reference home. Now, the reference home is a geometric twin of the rated home, and the reference home is defined as specifically configured to a standard set of thermal performance characteristics, which the energy budget that is the basis of comparison is derived from. So the reference home for an energy rating index score is using the 2006 IECC, which is the standard set of thermal performance characteristics that the rated home is going to be compared to in order to associate the energy rating index score to specifically there. Now, there are a variety of different reference homes that could be used. We have the IECC ERI reference home. We have the HERS reference home. We have an Energy Star reference home. You can imagine that there's also an area weighted U value reference home for that compliance option in the code. And then there could be a user defined reference home, which sometimes utilities might develop when they're thinking about demand side management programs here. So the reference design, again, is a standard set of specifications that generate the specific, consistent, and quantifiable energy performance in that house. Ultimately, it's the concept that the code uses to demonstrate compliance with the area-weighted U-value trade-off approach, the simulated building performance approach, as well as the ERI pathway there. So you take the house that you're actually evaluating, we often call that the rated home, and we compare the rated home to a reference home, and we want to see ultimately, is the rated home equal to or better than the reference home? And if it's equal to or better than the reference home, it's going to meet qualifications for code compliance or program compliance, depending on how you're doing that there. So again, the actual built home performance needs to be less than or equal to the performance of the standard reference home, or depending on the scale, it could be equal to or better than. So for like the area weighted U value path, it has to be equal to or less than. And actually, the simulated performance path, it's equal to or less than. Actually, it's equal to or less than in all these pathways. I'm sorry if I confused you there. So when we're talking about the simulated performance path, you'll see that the reference home is actually built into the code in this table R405.5.2 parentheses 1 there. But the reference home for the ERI pathway is built in the ANSI 301 standard itself there. Now, ultimately what we're doing again within the software is we're creating two houses that are geometric twins of each other. We're using the 2006 IECC prescriptive requirements as the reference home there. And we're on the builder side or the rated home side, it's whatever the builder wants to try to see will comply there. And ultimately the builder's house's energy features are compared to the reference home. And if they're equal to the reference home, it would be 100 on that scale. If it's better than the reference home, it would be lower on that scale there. So it would be less than 100 on that scale. And what we'll see when we start talking about the IECC energy rating index is that it's ultimately creating a threshold there, a target that we're trying to achieve here. Ultimately, we have this energy rating projected score. In this case, it's 64 because we're projecting what that house is going, how that house is going to perform based on its specifications. And then we have a confirmed report, in this case 47, that demonstrates how it actually performed out there in the field after it was built there. Now, moving over to the energy rating index for IECC, this is a compliance alternative or a compliance option. We often call it a compliance pathway through the code there. It is different than the HERS energy rating index score, and we're going to demonstrate how it's different here right now. Now, when it was adopted into section R406 of the IECC, they couldn't use a proprietary term, the HERS energy rating index. So they dropped HERS and they just utilized energy rating index. So energy rating index now is basically like the Kleenex, the Xerox, the Coke of the industries. It's this generic term that's used to describe an energy rating index score. And now that generic term has been, in essence, codified by entering it into the code, but also through the creation of the ANSI standard 301, which is a public standard that anybody can use to generate energy rating index scores here. Now, when you're using the energy rating index pathway, the R406 pathway, you still have to do all of the requirements that are listed in the code. There's specific insulation installation requirements, the air barrier, air sealing, and insulation table requirements, and all of those things have been summarized in the 2021 IECC in this table at the beginning of the R406 section. So you have to do that. Then you have to meet a specific energy rating index target score. You have to meet it or exceed it or be lower than it in order to demonstrate compliance. And then there's some things with regards to on-site renewables or off-site, or if they're included or not included, that create what we call backstops for compliance in the code here. In the 2021 IECC, we also have these additional energy efficiency packages that you have to choose from with regards to the energy rating index compliance option in R406. You have to demonstrate that your energy rating index score is 5% better than. So for climate zone 5, we would be required to get an energy rating index target of 55 or less. But because of the energy efficiency option requirement, it's actually 52 or less is the requirement that we have to achieve for code compliance in the 2021 IECC. Now, remember that the word mandatory has been removed from the code. So regardless of the compliance pathways, we have these requirements that are summarized in this R406.2 table here. Regardless of the compliance path, these requirements have to be maintained or instituted in that house. They're basically mandatory requirements here. They include insulation, attic eave baffles, all those types of things, but there are also insulation certificates, air leakage requirements, the air barrier and insulation installation table, duct sealing requirements, and more and more and more. Now we have to understand the backstops that have been put in because the energy rating index scale is an asset rating scale. When you put renewables on the house, like a solar voltaic panel, a PV panel on the house, you can drastically drive the energy rating index score down towards 0, which means that you potentially could have a poor building thermal envelope, but these backstops are designed to protect the building thermal envelope. And in this case, it says where on-site renewables are not included in the analysis, the building thermal envelope has to be 15% less than the U values that are described in the 2021 IECC. So in essence, the house has to be 15% better than the normal house built to the prescriptive U value table in the IECC here. So again, this is what we call a backstop, ensuring that the building thermal envelope is protected against on-site renewables here. If on-site renewables are included, then the building thermal envelope shall be equal to or better than the levels of efficiencies and solar heat gain coefficients of the 2018 IECC. So again, I can't trade off below those R values listed in the table below here. And then it goes further and says, for compliance purposes, any reduction in the energy use of the rated design associated with on-site renewables shall not exceed 5%. So I can't drive the score down below 55 or in order by putting photovoltaics on the house. I can only count 5% of the energy contribution of photovoltaic panels to that house, I can only count 5% of that contribution. And why is that the case here? So if I take this typical 2-story house, and you can see the energy features on the right side of the house here, these energy features would create an energy or HERS energy rating index of 100 on the scale. If I put on a pretty reasonable size photo PV system on the house, a 6.4 kilowatt system on the house, I've driven that house from 100 to 55 just by putting PV panels on the house there, not by installing better insulation or more house tightness or better ducts or anything like that there. So this is what the code is trying to protect the house from here. Now, the reference home that's used in the energy rating index score in the 2015 IECC was the mortgage industry standards in essence. It wasn't completely codified as that, but it's saying that you're going to use the 2006 International Energy Conservation Code. And the only way it was described to create the energy rating index software was through the mortgage industry national standards there. In the 2018 IECC, ANSI went through the process and created the ANSI standard that took Chapter 3 of the Mortgage Industry National Standards and made it an ANSI standard. And that became the standard that the Energy Rating Index for code was linked to in the 2018 IECC. And then in the 2021 IECC, they used the most recent version of the ANSI standard. And in the 2024 IECC, they're going to move to the 2022 version of the ANSI standard and link it to that. So you can see that each adoption cycle, they change the standard that it's adopted to. Now, we'll see here in a second, if we have time, that ventilation in these standards is ventilation as depicted below here by this equation on this slide here. And what you'll see in the adoption of the energy rating index standard in the code is that they amended it in the body of the code. In the body of the R406 section, they changed how ventilation is utilized or modeled in the software. Therefore, the HERS energy rating index or the ResNet energy rating index and the IECC energy rating index for the same house are no longer the same number there. So when we do this analysis, we have these geometric twins, and we're looking at the HERS reference design or standard 301 as the used for the reference home. But for the IECC, they actually amended the HERS reference home in the body of the code there. You can also see that the energy rating index target scores have changed over time. And the 2021 scores are the same as the 2015, although you have to remember that the additional efficiency package, the R408 section of the 2021 IECC, is making all of those scores in orange here be 5% lower. So in climate zone 5, for example, that 55 is actually a 52 target score, not a 55 target score here. When we talk about verification for IECC, the ERI compliance has to be completed by an approved third party, which generally speaking would be an energy rater there, and ResNet HERS energy rater. But verification of all those mandatory requirements shall be completed by the authority having jurisdiction or an approved third party if the authority jurisdiction is approving that party here. Well, I bring this up again because of the fact that when you're creating an energy rating index score, you generally don't care about how the insulation has been installed, for example. It can be installed poorly. What my job is to assess its installation in the context of creating an energy rating index score, not in the context of passing or failing code compliance there. So if a jurisdiction wants me as an energy rater to also look at how the insulation is installed, that jurisdiction really has to create an agreement with that third party with energy rater, and also potentially a scope of work to tell them how they want them to assess that insulation from the perspective of code compliance there. So it's an important point that we don't have enough time to really talk about, but you should think about that when you're utilizing the system for code compliance. Now, reporting is defined in the code. You have to do a compliance report to get your building permit. That's the projected building energy rating index score. And then you have to turn in a confirmed energy rating index score to get your certificate of occupancy here. This is an example of what the reports kind of look like in 2015. Remember that this is not a compliance report. This is the ResNet home energy rating certificate. It is not what the reports look like that you turn into your jurisdiction to get your building permit and your certificate of occupancy here. Again, you have to turn in a report that's proposed and a report that's confirmed, and the code details out what needs to be on those reports as well here. And this is kind of the generation of reports and how they've changed over time. The 2015 report did reference ResNet. That was taken off in the 2018 and the 2021 reports there themselves. Now, the 406 code, like I said before, in the 2015 cycle, didn't reference a specific standard. Therefore, and also because there was no true oversight of the software development for the IECC, we saw that the 2015 energy rating index score was the same for ResNet and for IECC here. The software developers, and it totally makes sense because the software developers use the same standard for how to develop the energy rating index, ResNet, and at that time they had not made that ventilation amendment in the body of the code in the 2015. When we get to the 2018 IECC, we see explicitly the reference to the ANSI 301 standard. This is the same standard that's used to calculate the ERI score. But again, during the code adoption process, the model ventilation rate used for the ANSI 301 standard was modified. So we see that the HERS ERI score uses the ASHRAE 62.2 2013 version of ventilation standard, whereas the IECC uses the 2004 version there, the 2004 version, I should say. So this is the largest reason or the biggest reason that the two scores are different there. But there is some more here. So for example, if I look at a house that's built to the 2018 IECC, it uses the 301 version that was developed in 2014. The 2021 IECC ANSI standard uses the ANSI standard that was developed in 2019 here. So we see that there could be some overlap of standards and energy rating indexes depending on when a code was actually adopted in a specific jurisdiction there. So that's really what we're getting at. And to also realize that the HERS energy rating index is a continual maintenance. It's always working on the ANSI 301 standard, regardless of its version. It's a continuous maintenance. So it's a dynamic score that's going to change over time here. I'm going to skip this part and just show you how the scores differ. So again, this is based off of the 2015 IECC. You can see that the score is the same here. It's 63 in the energy rating index from ResNet and in the code. But when we get to the 2018, there's a 63 for the home energy rating certificate from ResNet and a 74 for the 2018 IECC. And then in the 2021 here, it was 63 again, but it's 78 for the 2021 IECC. Now, just so you know, IECC, one of the softwares put in an interpretation request for to IECC to get an idea about why this ventilation issue has caused this score to diverge so much. And that interpretation request came back, and it appears that these scores are getting closer to each other, but they are never going to be exactly the same because they are working on slightly different standards there. Ultimately, what does this mean? It means that we need to be precise about our language when we're talking about an IECC energy rating index score or a HERS energy rating index score. We need to also decide when we're doing our adoption, are we going to amend the code to accept HERS energy rating index scores, or are we going to keep the code as it's written and use an IECC energy rating index score? My preference is that you would use a HERS energy rating index score because it just removes a lot of confusion there. And that's what you see jurisdictions like the city of Denver, for example, in their most recent adoption. They've amended the code, the 2021 IECC, so that it's just referencing the ANSI 301 standard, not the ventilation amendment that was incorporated here. So remember, you have compliance reports that are mandatory that you need to do regardless of the compliance option that you're doing. And let's conclude here. So ResNet HERS ERI is an asset rating. The IECC uses that asset rating as a target, a specific target that you have to meet or exceed, which means that you have to meet that score or get lower than that score. And that's based off of the energy specifications that are being specified for that specific house there. The scores will never be the same. The IECC ERI and the HERS ERI will never be the same. Adoption recommendation is to just reference ANSI 301, but cross out the ventilation amendment that was done there to simplify and get more alignment between the two scores and simplify some of the confusion that's out there. Energy modeling uses the same concepts for the UA compliance path, the simulated building performance pathway, as they do for the energy rating index pathway. And then ultimately going back to that idea of a approved third party. You need to know what you're approving the third party to actually do. Are they being approved to just create the energy rating index score, or are you also asking them to look at the house for compliance with the other requirements of the code, like how insulation is installed, how air barriers are installed, so that you are on the same page and you're moving forward in unison to get compliance with that code. Sorry, I'm a little bit over here. I'm Robbie Schwartz. This is my contact information. You can reach out to me anytime to ask questions, and I'm more than happy to stick around and answer some questions that might have come up during the presentation.
Thanks, Robbie. Yeah, I know that was a lot of information to cover in just an hour session, so you did a great job getting through as much as you could. And then just to mention, we are building out a resource, more like a reference sheet for folks that highlights the key items of the differences between HERS and ERI. So that'll probably be posted in the next couple of weeks to the Code Adoption Toolkit. So in the meantime, thank you all for attending. And for those of you who can hang on for just a couple more minutes, we've got a few questions for Robbie here. The first one is, will ResNet ever update the 2006 IECC to a more recent version?
Okay, so I believe that the question is asking if the reference home that's used to calculate the energy rating index would be updated. Anybody can make that proposal. It's an ANSI process. ResNet is just kind of the ANSI body that is coordinating the development of that standard there. So anybody can make that recommendation. Right now, the consensus is that it's not needed because it's basically just pinning a point on the energy rating index scale of 100 is equivalent to the 2006. So you can get an idea there. If you're trying to get to zero, you're still zero still means zero energy, regardless of if it was based off of the 2021 IECC or the 2006 IECC.
Great, thank you, Robbie. Next question is, can you explain why HERS for climate zone 5 goes from 55 to 52?
Yeah, that's because of the additional energy efficiency packages that were added in the 2021 IECC. You don't have to pick a package. You just have to ensure that the house is 5% better than its target, and 5% of 55 equals 52. So that's your new target is 52.
Perfect, thank you. And the age-old question, will ResNet and IECC ever get married?
In terms of the scores, the IECC, they never, I don't think they ever can get, because the IECC has to pick a ANSI 301 standard version, and that version becomes fixed in time in essence, whereas the HERS energy rating index score is dynamic and flows with the standard development of the ANSI 301 standard there. So I don't think they'll ever get married. What I do think will happen is that IECC, I think IECC's relationship with ResNet is getting closer and closer. So you can in essence say that they're going to get engaged, and they will stay engaged, I think. And I think the thing that we're going to see in the future is that IECC is going to request that ResNet is the oversight body for software calculations that are used for all energy code compliance, not just the ERI compliance.
And I saw in your, I think it was the last slide, where you suggested that when jurisdictions are going for adopting amendments, potentially amending out the specific, was it the specific year and the ventilation requirements?
Yeah. So if you amend out the specific year and the ventilation requirements, then it becomes basically the HERS energy rating index score. And
Great,
that's what some jurisdictions have done.
All right, one more question for you. Table R405.2 requirements for total building performance in the 2021 code cycle references code sections for energy compliance. Have you ever asked a builder to identify energy compliance based on this table?
Yes, I mean, we are supposed to. Most of those things are field verified there. So for example, attic eave baffles would be one of those. Just because they're doing the performance approach doesn't mean that attic eave baffles can be traded off. So that table is the reason the word mandatory was removed was because people had the misconception that things that used to be labeled as prescriptive, like attic eave baffles, were not required when you did the performance option to the code here. So all of those things, all those installation requirements that are listed in different sections of the code have been summarized in these tables, and they have become requirements. So in essence, if they didn't install the attic eave baffle, they shouldn't comply with the energy code. Most of those things are field verified, not modeled there. Everything that is associated with an R value, a U value in the code is something that can be traded off. And those things are things that would be modeled in the three approaches that use energy modeling. Those things that are required by the code that are installed are required regardless of the compliance option that you actually choose.
Thanks, Robbie. Yeah, and I know in we were just talking previously about the Denver checklists, and they've made a point to call out a lot of those R405.2 table requirements in the checklist that designers have to go through when submitting for permit.
Yeah.
So
Yeah.
it's something that's definitely on people's docket to
Radar,
check
yeah.
for.
And-
Radar. That's the word I'm looking
Yeah.
for. Thank you.
Just remember that if you're in the process of adopting, you might want to look at that table and also the true requirements in the body of the code, because they don't match each other, and you might want to add some additional things to the table there.
And Robbie is a great guy to reach out to if you have any questions on additional amendments for that specific table. But with that, I will thank Robbie for the presentation today and for you all attending. I'll send out certificates of attendance in the next week or so. And the webinar recording will be posted in addition to the PDF of the slides in the next week or so as well. So we hope to see you at our next webinar in a month or so.
Great.